So today we are going to be discussing the forward pass, and this is tutorial 5 of our neural network for dummies. And we are going to discuss the forward pass, but before we do that, I will like us to solve this assignment. So this is the assignment I gave from the previous tutorial, that is part 4 of neural network for toddlers. So what did you get as the outputs of this network? We have X and we have Y. So how do we derive or how do we compute the value for Y? Let's do it right now. So the first thing you want to do in a network like this is to figure out how many layers are in this network. So in this case, we have 2 layers of this network. We can cut it out from right here. So you have the first layer made up of just 2 neurons and the second layer made up of 1 neuron, right? The first layer takes 2 inputs and the second layer takes 2 inputs and produces a single output. So let's see how it goes. So the first thing we are going to do, we are going to calculate the outputs of these neurons here, and then we are going to use this output and apply it to this second layer and then calculate Y using linear combination as we learned before. Okay, so let's go ahead to solve it right now. So the first thing you have to do is this is X1 and X2. So we have X1 going in here and X2 going out here. So this is pretty much easy. So here we have the output going out from here, let's call it Y, and the one coming out from here, let's call it Y prime. So here we are going to calculate Y. So what will be the value of Y? We are going to multiply X1 with W1 and add the bias. X1, W1 plus bias, right? So we have X1 dot W1 plus A1. So this is the value of Y here, right? So this is Y. So we can call this Y1, and this second part we call it Y2. Now we have our Y1 calculated. Let's now calculate Y2. Sorry, let's calculate Y1 prime. So we've not gotten here, we are still processing this layer. So this is going to be, so we are going from here, so we have X2 W1 plus A1 prime. So we have X2 W1 prime plus A1 prime. So we have X2 dot W1 prime plus A1 prime. So I think this is fair enough. So at this point we have our Y1 and our Y2. Actually this is not Y2 but Y1 prime. So we now have the inputs to this network right here. So one thing you can do in a situation like this is you can actually then adjust this network, like erasing this part of it, of the network, and then applying Y1 prime and Y2 exactly the same way you apply X1 and X2. So let's go ahead to do that. So let's calculate the value gotten from the input Y1. So if Y1 goes here, it's going to give us an output which is Y1 going in here W2 plus this bias. So this is what is going in here from this branch of the network. So we are going to have Y equals the final output Y2 equals Y1 plus Y2, right? So at this point, we have to consider one of the branches after the other one. So we have to consider one edge after another. So applying this input here, we are going to have, from this edge, we are going to have Y1 W2 plus A2. So we are going to have Y1 dot W2 plus A2. So this is what we have going from here, and we are going to add it to this input coming from here. It's going to be plus. Remember we talked about linear combination, so we do a plus and we are going to add this, and this is Y1 prime. So it's going to be Y1 prime dot W2 prime right? And it's going to be plus A2 prime. So this is the output of this network. However, these internal variables here they are actually not part of the network. So we actually have to replace these variables in our output, right? So we have y1 prime and y1. This y1 and this y1 prime, we are going to replace it because we already calculated them. So let's get the final output by substituting the values, the expression for y1 and y1 prime. So here we are going to have, if we place this value in this equation, we are going to have x1, right? So we are going to have x1 w1 plus a1 dot, so we have here, we have w2. So here we have this equation which represents this plus a2. So we have the first part, and let's now take the second part. So let's now take the second part. So here we are going to have plus, and we substitute for this, we are going to have this expression here. We are going to have x2 dot w1 prime plus a1 prime. So we have this expression here, right? This expression, and it's going to be the w2 prime plus this term here, which is a2 prime. So this is the final output, and this is the value of y. So this is the value of the final output. So one thing you can do to verify this output is correct is that it doesn't contain the intermediate terms. And secondly, this final result of these outputs will contain all the weights and all the biases of the network. So let's verify that all the weights and biases as well as the inputs are represented in this equation. So let's begin with x1 and x2. x1 and x2 we have, so x1 and x2, right? We have x1 and x2. w1, a1, we have w1, a1. w1, a1, w1 prime, a1 prime, we have w1 prime, a1 prime. w2, a2, we have w2, a2. w2 prime, a2 prime, we have w2 prime, a2 prime. So all the weights and biases of the network contribute to the output of this network. And this is the concept of the forward pass. So when you derive an expression for a particular layer, you are going to apply it to the second layer to get the output of the next layer, and you apply the same thing to the next layer to get the output. And at the end of the day, you are going to have an expression that contains all the weights and the biases of this network. And this is very important because later on when we are going to be talking about partial derivatives and backpropagation and weight updates, this is going to be crucial for you to understand exactly how the final output is derived based on all the parameters of the network. So I would like to stop here. I would like to thank you for viewing. Remember, if you've not subscribed to the channel, please hit on that subscribe button to subscribe to my channel, and please support me in other ways, and we'll see you in the next part.